Hello everybody and welcome to the tutorial of week 3 of the course, in which we still look at process analysis and especially at Little's Law. Well, in the real life tutorial we had a quiz up front, but since the quiz is only repeating the lecture, I decided to not film the quiz because you actually have all the other material already available online, so the quiz would just be repetition. So we can actually focus on the tasks only. So we'll first of all look at Little's Law in a clinic. And well, the idea here was to use the formula of Little's Law, which you can also see next to me. So Little's Law actually says you have the lead time equal to the work in progress divided by the throughput. So here we assume that patients arrive at a rate of 20 patients per hour and stay an average of 2 hours in the clinic. What would be the average number of patients at the clinic? And that's something we have to find out. So the arrival rate, or also the throughput, is 20 patients an hour. The waiting time for one client from the start to the end is 2 hours, and the customer's waiting would be the work in progress. So what we have to do actually is have a look at, well, we want to know what the work in progress is. If we look at the formula again, the work in progress does not stand alone. So what we have to do actually is we have to, so it was the lead time equal to the work in progress divided by the throughput. We have to multiply the whole thing with the throughput to get the work in progress standing alone. So this means in the end then work in progress stands alone equal to the throughput multiplied with the lead time. And well, the throughput was 20 patients an hour. The total lead time was 2 hours, giving us 40 patients in total as work in progress. And that was the first part of the task. So let's look at Little's Law in services, so in the banking industry. So here we have a queue of 6 customers. We have an exit rate or a throughput rate of 12 customers an hour. And the question is, what is the average time in the system? So the whole time a customer spends in the system. And so what we're searching for essentially is the lead time. So lead time is actually already, let's say, the original Little's Law formula. So lead time equals to, as said before, work in progress divided by throughput. So what we simply have to do is, so work in progress as customers divided by throughput. Lead time is the work in progress, so 6 customers waiting in the queue, divided by 12 customers that are exiting per hour. And this gives us half an hour of lead time in the bank. So customers on average spend half an hour in the bank from start to finish. And then finally, we have a discussion on this picture. So why would organizations with optimized production processes might still encounter deficiencies as a whole? As said, this car is a very fast car. And this one is also a very fast car. You fueled the car, so the car is maintained. So with the car, everything is okay. But if in a process, and this is of course just a picture to represent that, if you have a sheep in the process, so a bottleneck, something that slows you down, then the whole process, no matter how fast it can be, is slowed down. So this car can drive 200 kilometers per hour, but it only can, let's say, drive 2 kilometers per hour, or whatever, something like that, because there's something that limits the process, the speed of the car. And so even though we optimize everything, or a lot of things, you have to make sure that the bottleneck is not actually harming your process. In this case, it definitely is. So you have to make sure that you either give a turbo to the sheep or that you move the sheep to another place. And that is the homework for today.